Okay, so in this particular question, we have to find the value of P such that the lines L1 and L2 given to us are perpendicular to each other, right? So first of all, since the equation of line which are given to us are in Cartesian form, let us look at the standard equation of line in Cartesian form. So it goes something like this: x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. This is the Cartesian equation of a line which passes through the point x1 y1 z1 and has direction ratios a comma b comma c, right? So if there is, let us say, this line, this general line L, then it passes through, let us say, this point x1 y1 z1, and if it has direction ratios a b c, then basically a vector in the direction of L can be written as a I cap plus b j cap plus c k cap. This much knowledge is sufficient to solve this particular question. Okay, so if you now look at the equations which are given to you, first equation L1, we will convert this equation in the standard form, right? So when I say standard form, I should have the variables x, y and z with coefficients equal to 1. So whatever is required, we will do those things to get this standard form. So my L1 will now become x minus 1 upon minus 3, just multiplied minus 1 in denominator and numerator, is equal to y minus 2 upon p by 7, just divided by 7, is equal to z minus 3 by 2. Now this need not be changed. And similarly, your line 2 will become x minus 1 upon minus 3p by 7 is equal to y minus 5 upon 1 is equal to z minus 6 upon minus 5. So now when I have converted this in the standard form, now I can directly compare these values. So basically L1 will have direction ratios minus 3, p by 7 and 2, which means that if I want to write some vector, let us call it a vector, in the direction of line 1, then that vector can be written as 3i cap minus 3i cap plus p by 7 j cap plus 2 k cap, right? And if I have to write some vector, let us call it b vector, in the direction of L2, then it can be written as minus 3p by 7 I cap plus j cap plus minus 5 k cap. Okay, so these vectors are in the direction of line L1 and L2. Let us say if this is line L1 and this is line L2, then now I have my vectors a vector and b vector, right? So what is the condition given to us? That these two lines are perpendicular, which means that these two vectors are also perpendicular. And if two vectors are perpendicular, then we have the condition that a dot b is equal to 0, right? So if you apply a dot b, what will happen? You will get 9p by 7 plus p by 7 minus 10 equal to 0, which on solution will give you value of p as 7. So here we complete the first part of the question where we were supposed to find the value of p. Now in second part, what we have to do? Also find the equation of line passing through the point 3, 2, minus 4 and parallel to line 1. Okay, so if two lines are parallel, let us say this is the required line, this line is parallel to line L1. Okay, so basically the direction ratio of L will be same as direction ratio of L1 because both are parallel to this small a vector, right? Okay, but the values of x1, y1, z1 will change. Now my required line passes through 3, 2 and minus 4. So using this particular data, I can write one equation here. Equation will become x minus 3 upon minus 3, right, is equal to y minus 2 upon p by 7, but since value of p is equal to 7, it will become 1, is equal to z minus minus 4, which is z plus 4 upon 2, right? This particular line has same direction ratios as line 1 and also passes through 3, 2, minus 4. Thus this becomes our required line.